All right, so we're moving on to example 3, where we are going to prove that two triangles are congruent. Um, so it says, what are the corresponding sides and angles in triangle FHJ and triangle KHG? Prove the triangles are congruent by completing the proof below. So when you have overlapping triangles like this and we need to prove that they are congruent, I like to start by finding the two triangles. What I mean by that is I'll go to the picture and I need to find triangle FHJ. There's a lot of triangles in this picture, so I want to make sure I'm looking at the right one. Oh, that's kind of a big highlight. So FHJ. All right, so there's one triangle. And then I want to highlight the other triangle. Maybe we'll do a smaller highlighter. So KHG, KHG, there's our second triangle. So what that helps me see is that they do have a shared part that's part of both triangles, and that shared part is this angle H. Do you notice that angle H in this triangle right here is the same angle H as this triangle? So they overlap, which means angle H will be congruent in both triangles. So that's going to bring in our reflexive property. But before we get there, I want to separate these two triangles. Let's draw them out. I will try my best to draw the triangles. So here is H, J, F. And I want to bring over any congruency marks that might be there, so I know that angle F already has a congruency mark. And then the other triangle is looking something like this, where this is H up here, G, and K. And we've got that congruency mark. When we look at the triangle, we can see, do you see this side FJ? FJ. I can see that FJ is made up of two smaller segments. This one has two congruency marks. This one has one congruency mark. Those combined together give us the entirety of FJ. Now, if I look at KG, do you see how this whole segment is made up of two smaller segments with those same congruency marks? So two congruency marks, one congruency mark. So that entire segment will be the same as this entire segment. So I'm going to go ahead and mark that congruency in the picture. FJ will be congruent to KG. All right, let's start filling in our proof. So first statement, something that is given. I'm going to write out those angles first. We said that angle F was congruent to angle K. We know that to be true because that was given to us in the picture. Sometimes our given information is written out for us. Sometimes it's just provided for us in the picture. I did not use three letters to name this angle F because when I look at F, I can see that that's the only angle right there. I could have said angle HFJ, but I think we're good with saying angle F is congruent to angle K. All right, the other thing that was given to us in the picture is this congruency. FJ is congruent to KG. We already talked about why those are congruent, so let's go ahead and put those in the picture. So segment FJ is congruent to, and then because we started F to J, we want to follow that same order in our second, or in the end of our congruency statement. So we are going to start with KG. That would be the proper order for that. All right, so far we have an angle that's congruent. Actually, I don't want to write that there. We're kind of tracking our congruencies. So far we have an angle, we have a side, that is an S, not that you can tell. A little better. All right, now I want to go back to this angle H that was shared by both triangles. Angle H in this triangle is going to be congruent to angle H in this triangle, and that is the reflexive property. It's like a shared side, an overlapping shared angle. I am going to use three letters to name this angle though, so that I can differentiate that angle H in one triangle is congruent to angle H in the other triangle. So I'm going to say angle FHJ. So FHJ, where H is the vertex, actually let me mark the congruency, is congruent to angle. Now I have to follow, if I went FHJ, I'm going to go KHG, where H is the vertex. I'll go ahead and mark the congruency. And then we said that was angle KHG. That's the reflexive property. So we have another angle that is congruent in this picture. So when we have two angles on a side, our triangle congruence options are angle, side, angle, or angle, angle, side. Now, yes, I can see that it's already filled in for us, but let's make sure we understand why the triangles are congruent by angle, angle, side. So we have two angles that are congruent. Now, for it to be angle, side, angle, that would be two angles in the included side. Do you see how the S is in between the two angles? Well, that's how it should look in the picture too, where the side is in between the two angles. So that would be this side right here, which is not our congruent side. Our congruent side is actually this one out here, this one out here. It's not included between the two angles, so that's what we call a non-included side. So we have two angles and a non-included side. That's what angle, angle, side looks like. So these triangles are congruent by angle, angle, side. So we'll say triangle FHJ is congruent to triangle, and then I want to follow the same order. If we went FHJ, we have to start with KHG. And we have just proven the triangles are congruent.